and start it back up so that it'll all fit. I can't go beyond 15 minutes and it won't load to YouTube. So that's the applied force in the x direction. So in the y direction, we're going to do the same thing, but in the y direction, so when I solve for the applied force in the y direction, it's going to be the hypotenuse times the sine of the angle. Because if you look at the picture, the FAY is the opposite side from the angle. So opposite divided by hypotenuse is the sine of the angle. So I want to get this, I know that, and the angle. So we're going to get the applied force, 63.5 newtons, times the sine of 34 degrees. And that will equal, better equal less than 52.6. Looking at the picture, I would say probably in the 30s. It looks like about half of the other one on my picture. What do you get? What is it? 35.5. So what you do is you just solve things in the order that they can be solved. And I want to tell you another thing. When you're making your descriptive equations, this applied force has now been replaced with these two. So don't have, like I've had people who they write their descriptive equations and then they also have FA down here because there's an FA on the picture. This arrow has been replaced with that one and that one. So this one is as if it's not even there anymore. These are now the arrows on the problem. And even though the arrow is way over here, it's happening over here. Because look, this is where it connects to the object that's moving. So to make a triangle, I have to put it over there. But I could have gone up and over, and you would have seen it over here, closer to the object that's being moved. So these three are our x vectors, and these two, are our y vectors. These three are our y, and these two are our x. So now that we have FAX and FAY, what can we solve for next? Looking at, you've got available to you the descriptive equations. You also have friction equals mu Fn, W equals mg. So what can I now solve for based on now knowing FAX and FAY? Is there something that I now can solve for? Yes? This one? Okay, well this one, but which one am I going to solve for now? Well, I already know W. It's right there. Because you're right. This is the formula. This is the equation I want to use. But what's the unknown here? Fn. I know what FAY is and I know what W is. So I'm going to rearrange this equation. So I'm going to rearrange this equation to solve for Fn. I'm going to move the W to the other side, which would make it positive. And I'm going to move the FAY to the other side, which is going to make it negative. So solving for Fn, I'm going to get Fn is going to equal W minus FAY. Okay, the normal force is going to equal W minus FAY. So the W is 50 newtons minus FAY is 35.5 newtons. And that's going to equal, looks like that will equal 14.5 newtons. So there's your normal force. So you basically just solve things as they open up and become available to solve, and eventually you'll get to the thing that they're asking for. So what's the next thing we can solve for? Friction, because I know mu and I know the normal force. If I know both of these, I can get friction. So my friction is going to equal mu Fn. Notice what I'm doing here. I'm showing the formula before I plug in. It's important that you do that because in physics, you have a responsibility as a problem solver to communicate your solution to the problem. It's not enough just to have the right answer. You need to, this is all part of physics, doing the communication of your solution. So I need to clearly communicate what I did to come up with the answers that I got. So the mu is 0.23, and the normal force is 14.5 newtons. So if you solve that, what do you get? 3.34, but guess what? I'm only going to write 3.3. Now I know the rule that I told you was 3 significant digits, but the reason why I'm only using 2 here is because if you look at the problem, we've been solving everything to 3 significant digits, and that's given me numbers to the nearest tenth of a newton, tenth of a newton, tenth of a newton. So I want this to be consistent with all the other numbers that I'm adding and subtracting so that they're all to the same degree of accuracy. So now that we know friction, all right, what can I now solve for? Yes, acceleration, that's the only thing left, right? The acceleration is the only thing left, and I'm going to use this equation to solve for it because I know m. Oh, wait a second. We didn't solve for m yet. We know these two, but we still need to solve for m. So we have to do that. So m, right, is weight over gravity. So it's going to be 50 newtons divided by 9.8 meters per second squared. And what is 50 divided by 9.8? 5.10? See, because this isn't a force, I still, my rule is 3 significant digits until you get to some point where, like where the force I was down to 2, so it would be consistent with the other numbers. But mass is a different quantity. So now that I know that, now we can solve for the acceleration. So I'm going to take this equation, and all I have to do to get a is move the m to the other side, which means I'm going to take this and divide it by m. So we're going to have a is going to be FAX minus friction divided by the mass. Oh, let me do it below because it looks like I don't have a lot of room there. So A equals FAX minus friction divided by the mass. Put in those numbers and you'll have the answer. So the applied force in the x direction was 52.6 newtons. So 52.6 newtons goes right there. The friction I can see is 3.3 newtons. And the mass is 5.10 kilograms. And so solving that, and that's going to be your answer. That's what they ultimately wanted. And what is that? 9.7 what? The 3 significant digits. 9.66? 9.67. Now you might say, I'll stop the podcast here.